can't trust me, as Jalen just found out. Can never be trusted. All right, so from a point on a level ground, 125 feet from the base of the tower. There's my tower. There's my point on the ground, 125 feet. The angle of elevation is 57.2 degrees. Approximate the height of the tower to the nearest foot. So you need a calculator. And our height is here. And this is just SOHCAHTOA. So far I'm telling the truth. This is a break. Now, what's my equation, Zach? Good. And then to solve this, I'm just going to multiply both sides by 125. Now, on a multiple choice non-calculator test, that might be the answer option that you would choose. When I type this into my calculator, what do you have to remember? No, what? Not second-tan. I am keeping it in. I'm just taking the tangent of 57.2. You only use inverse tan if you're looking for the angle measure. We're not looking for the angle measure here. We have it, but I heard someone tell me what I was looking for. What did you say? Yeah, you need it to be in degrees because your angle is given in degrees. So if you have it in radians, which you probably do, go to your mode, change it to degrees, and then just type it in. 125 times the tangent of 57.2. And they want the height to the nearest foot, 194 feet. You like that? Okay. Well, it's going to get a little harder, I think. You're taking your first hot air balloon ride. Anybody ever been in a hot air balloon? I think I did go in one once at like a fairgrounds where it was really, I think I was little. I think it was like pinned down to the ground and like you went up, but you were like held down. No, I was in one. I just didn't like go on a free-flying flight. Okay. You can take hot air balloon over Letchworth State Park, and I want to do that. Wouldn't that be cool?
That's the one thing I don't want.
Your friend is standing on level ground 100 feet away from your point of launch. That's my hot air balloon.
It's like a jelly bean.
It's deflated. All right. Oh, it's not. Your friend is standing 100 feet away. At one instant, the angle of elevation from your friend to you is 31.7. So this hot air balloon's going up. So at one instant, the angle of elevation was 31.7 degrees. 1 minute later, the angle of elevation is bigger because this hot air balloon's going up. And now is 76.2. So what's 76.2? So we can label this one appropriately. Minus the 31.7 that's already accounted for is 44.5. Okay. How far did you travel to the nearest tenth of a foot during that minute? So which piece are we looking for? If it's how far I traveled in that minute. The small top piece. Perfect. That's truly what we're looking for. Okay? But we're not going to find that directly. This is going to be a two-part process. We're going to find the larger piece, because that's a leg of a right triangle. And then we're going to find this piece here, because that's a leg of a right triangle. And then we're just going to take the difference. Yes? Okay. So let's start with the big leg. What equation is going to help us find, we'll call it y. What's the equation that would help me find that? Tangent of 76.2 equals, well, I called it y, so I'm going to stick with y. Y over 100. And so y is going to equal 100 times the tangent of 76.2. That's 407.127. Done on the calculator. And then I have to find this length. This one I'll call x. What equation, Kendall, will I use to find the length of x? Nope. Good. So x is going to equal 100 times the tangent of 31.7, which is 61.761. So now to find the distance you traveled, you just need the difference. So 407, so calculation 3 is 407.127 minus 61.761. You can use the longer decimals that are on your calculator. And I get to the nearest tenth of a foot, 345.4 feet. Did we get all that? What if they asked you the speed? Speed is the change in distance over the change in time, right? 345.4 feet per minute, which is how much per second? 345.4 divided by 60 seconds.
Wait, you wouldn't use around the decimal range.
I'm not on my calculator. Which would be 5.8 feet per second. How many miles per hour is that? You think? 5 feet in 1 second? I think that's pretty slow, to be honest. No. Okay. All right. Exercise 3. Adam, this reminds me of your brother. I'll explain when we're done. A boat leaves the entrance to a harbor and travels 25 miles on a bearing of north 42 degrees east. So in the navigation world, bearing is just kind of your direction. So north 42 degrees east is, here's your kind of compass with north. 42 degrees east is there. Okay. And he travels 25 miles in that direction, so I won't put an arrow in the end. I'll just put a point to end the segment. Okay. The captain then turns the boat 90 degrees clockwise. So if he goes 90 degrees clockwise from here, kind of making that a 90-degree angle, do you see it? But he's turning from here, so that's this. And travels 18 miles now on a bearing of southeast 48. So I think this is always tricky. So the bearing is your degree measurement relative to the vertical line. So what we have here is, and this is going to be why this 48 southeast makes sense, because with two vertical lines, we have parallel lines. With this, we have a transversal. So what's this measure? 42. And this angle and this angle were supposed to together make the 90, which is why this is 48 degrees. So that's 48 degrees off of the vertical line. In the southeast direction. Does this make sense? So the fact that we turn 90 degrees and the fact that our bearing is now considered southeast 48, that all should make sense and add up to the 90 to get the alternate interior angles and so forth. Bearings are the angles created with a vertical north-south pole. Okay? My knowledge of navigation directionals with degrees that they used in boating in the middle of the ocean, so they all are on the same page as far as what direction they're going, and in aviation, Adam, which is where your brother comes into play, because my knowledge of this is exclusively limited to where I've seen it in math textbooks. What Adam's brother Alex told me, who's a pilot, was, I don't remember what he told me, but he clarified some things. So it was nice to have a pilot in the room, which is why this reminds me of your brother. Anyway, side story. So then the question is, how far is the boat? Oh, he did this for 18 miles. How far is the boat to the nearest tenth of a mile from the harbor entrance? So from start to finish. Okay. So, well, that's an easy question. Pythagorean theorem. They made. I wanted to go through the instructionals on the degrees anyway because it will come up in problems. But they gave us 25. They gave us 18. They told us it was a right triangle. And so to find this distance, 25 squared plus 18 squared equals d squared. So this is 949 equals d squared. Square root of both sides. D equals to the nearest tenth, 30.8. Good? So when you see bearings, it's the angle measure off of the north-south pole. Okay? If you're thinking of like a compass. All right. A ball on a spring is pulled 4 inches below its rest position and then released. The period of the motion is 6 seconds, so it does one full cycle in 6 seconds. Write the equation for the ball's simple harmonic motion. So this is just a simple harmonic motion is just a cosine or a sine curve with an amplitude that can adjust and a period that can adjust. It's not going, simple harmonic motion is, I don't believe, going to be shifted to the left or right at all or shifted up or down at all. So there's no shifts. So this particular, if you can envision, a ball on a spring is kind of like the diving board question, trying to envision the curve. If it's pulled 4 inches below its rest position and then released, there's one cycle. Okay? That cycle, they tell us, took 6 seconds. And it's a cosine curve with an amplitude of what? 4. What's the A value? -4, because it's a negative cosine curve. And then this W here, that's no different than the B. It's just in simple harmonic motion, they use a Greek variable. So our period equals 2 pi over B. and they've told us that our period is 6. So we just need to solve for B, which is going to be what? Pi over 3. So 6B equals 2 pi. Divide both sides by 6. Pi over 3. Good? Right. So A is -4, but the absolute value of -4 is 4. 4 is the amplitude. Amplitude's always positive. The A value can be positive or negative. Any questions? Okay. A mass on a smooth table is attached to a spring. The mass moves in simple harmonic motion described by this. So, quick sketch. Amplitude of 10. Period equals 2 pi over, our B value is pi over 6. Keep, change, flip. Our period is 12. Find the maximum displacement. What's that, do you think? What did you say? Okay, so what's the maximum displacement? Number answer here. 10. It's like the amplitude. Different way of saying it. The frequency. Was it this class someone asked about frequency? Yeah, we don't focus on it as much because frequency is the number of cycles that are going to be completed by 2 pi. Frequency is just the reciprocal of your period. Yes? So if our period is 12, what's our frequency? 1/12. So, and that, here's why that makes sense. Because frequency is the number of cycles completed by 2 pi. And 2 pi is... Yeah, that doesn't make sense to me. Because 6.28-ish would be here. Right, which would still be 1/12. That doesn't make any sense. No, let's not. Let's brainstorm. What did I do wrong here? The time required for one cycle is 12. But you can't tell me we got 1/12 of a cycle in by 2 pi. 1/12 of a cycle. Well, we got over half of a cycle in by that point in time. I wonder though, you know what, I think it has to do with the fact that this is in seconds and our scale 2 pi is 2 pi radians. There's a little hiccup there. Let me see where I stole this answer from and just make sure we have, I think we have the right answer. I think it's not making full sense because the scales are different. We're kind of looking at something in seconds. They're looking at something in radians. That's my gut. Still not positive. But we're going to find out. Because I always steal my problems. A mass on a smooth table. Maximum displacement, 10. Frequency, Okay, so frequency, since we're in terms of seconds, our frequency is the number of cycles in 1 second, not in 2 pi. Does that make sense? Okay, when we're labeled in terms of radians, it's the number of cycles in 2 pi, which is 1 full circle. Here, it's the number of cycles in 1 second. Are we good with that? That makes sense. 1/12 of the cycle in 1 second. Sorry, I didn't mean to confuse you on that one. And our time required is 12 seconds, so we got that. 1/12 of a second, and this time required is 12 seconds. Okay? For your homework, we're just going to add on to what's written there. Sorry. That is last night's homework, but just the 3s and the 9s, because I wanted you to practice more of that. Okay? No, but the same sections, but just 3s and 9s. The word problems won't be that hard.
Are you sure?
Let me look. Well, first of all, here's the first part of your homework. I mean, that's going to take you all of 2 minutes. And then finding the bearing based on a picture. That's not going to take long. And then, what's this? That's just writing an equation. This is real easy.
For you, you're a math teacher. Yeah, this is your job.
Yeah, no, you're fine.
You have this stuff memorized.
You'll survive.
I've known it for all along.
It'll make up for that other night where you